Honorable Director, dear colleagues and students, today is the 10th day of the Swachhata Pakhwada 2024, which we are celebrating as the World Technology Day, with an aim to commemorate the achievements of scientists, researchers, engineers and others involved in the field of science and technology. We have among us today Dr. Subhadeep Datta, Associate Professor, School of Physical Sciences, who would be presenting a talk on use of new technology and research for better cleanliness. May I request Dr. Datta to kindly come up and have a seat, please? I would request our Honorable Director, Professor Aurinder Banerjee, to kindly register. Madam, I would request you to kindly felicitate sir, please, with the bouquet. I would request sir to kindly come up for this talk, please. Thank you.
Go to the password. So good afternoon, everyone. First of all, thank you very much IACS administration for giving me this opportunity to talk about use of new technology and research for better cleanliness. At the outset, I should mention that I am not an expert in this field, and I didn't do any research on these type of things. So I gathered some information, which is a learning experience for me for the last 2-3 days, to find science behind cleaning, which is very elementary. I mean, even a class 10 or class 12 student can understand that. So it's not a loaded presentation. It will be easy. And then at the end of the presentation, I will show you let's say a stretched imagination where we, from our lab, what we could do with this idea, cleanliness, and linked with some technology devices. Okay, so clean is a very simple word, right? I mean, our day-to-day life, we always give gyan to people that let's be clean, let's make our environment clean. So that's the elementary discipline what we should follow in our life. So of course our life at IACS is not different from our home. So we must follow some discipline regarding keeping our campus clean. Of course, thanks to our cleaning persons, every moment they are giving effort to make our environment, make our space clean, which encompasses everything. I mean, from the start of the lab to the outside environment, plants, roads, streets, parking area, ponds. You would see everywhere there is active effort where we warm our environment, our adjacent space to be clean. And definition of cleanliness is very simple. If you can see it clean, it's clean. And if you can see, you cannot see, no, there comes science. Science can see what you cannot see, so instruments can see if there is a microscopic uncleanliness in the system. So we have very sophisticated machines in the lab where we could see that's unseen uncleanliness in the system. Okay, so but for the initial part of the system, I mean, I would go for a very simple things, good cleaning agent and different types of cleaning agent. And then types of cleaning agent and application of cleaning agent. Of course, this is the main thing, dust, dirt, stain, other unwanted substances from the surface which we want to be clean. Dust settle on the surface can be removed by normal dusting, but when dust comes in contact with the grease, oil, be careful. Grease and oil are moisture, then cleaning agents are required. So that's the most difficult part of it, right? If the dust comes to the contact of grease, oil or moisture, and there comes your new technology. Of course, washing, I mean, we are familiar with this, water and cleaning agent. This is usually done with sandpaper where friction is required, so abrasive. Static electricity, which is mop sweeper. Vacuum cleaner we use. Suction, force pressurized water. Sweeping before dusting, these are the normal protocols we use. Damp dusting, only after dust has settled down. And mopping by using hot and clean water and a neat mop. So types of cleaning agent, water, of course, that's the simplest thing. Hard water, hardness is in water is caused by the presence of calcium and magnesium ions in the water. If water contains more than 60 ppm of calcium and magnesium, it's called hard water. So temporary hardness is caused by the presence of bicarbonates of calcium and magnesium in water. Chemistry students, if present, they know, or material science students, they have clear idea about it. This can be removed by simply boiling the water. Permanent hardness is caused by the presence of sulfates, chlorides of calcium and magnesium. Now this is the most important part, removal of hardness. Alkali method, the alkali calcium hydroxide is used to remove the hardness. Lime soda method, sodium carbonate and calcium hydroxide both are used. Even sodium hexametaphosphate, which is difficult for me, but again, these are the things which can be ions which form complex salts, and this is known to us. Zeolites are hydrated silicates of sodium and aluminium. These are used for exchange process hardness is totally very low. Now, we loosely use detergent, right? This word detergent. They are cleaning agents used in conjunction with water. There are two types, soapy detergents and synthetic detergents, which is non-soapy. Active ingredients in soapy detergent, active ingredients are obtained from natural oil and fats. The active ingredients in synthetic detergent are in contact with the surface active agents or surfactants. Even we use builders or additives added to the detergent, these may be bleaching agents. We know we use bleaching agents for more active detergent activity. Liquid synthetic detergent, there are light duty detergents, which is for light soiled clothes or light soil on floors. They do not contain any bleaches or oxygen for oxidation. Powdered synthetic detergent, they have multiple properties in the sense that ingredients can be very varied for multiple purposes. So they can be used for washing floors. Regularly they are using this. Types of detergent, soaps, right? The simplest one, soaps. Made by the process of saponification. Usually in, I can remember I learned saponification, this word, during my class 12 chemistry, wherein fat or oil is subjected to alkali treatment. It is in anionic surfactant are more effective in soft water. Scum formation takes place because there is calcium and magnesium ions which reacts with the hard water. So placed in hard water and it is not easily rinsed away. Synthetic detergents, which is soapless, they have replaced soap because they have good emulsifying power as well as the suspension power. So this is a good quality of a good detergent. So let's go one by one. Good wetting power, very important. Good emulsifying power in breaking down fat and grease. Good suspension power, you have to suspend this. Soluble in all forms of water, effective over a wide range of temperature because temperature varies. So it should be effective over a specified temperature window. It should be biodegradable. We are very conscious for that. For the moment, because something which is not degradable, it's damage for the society. Not damage fabric or affect hand. Clean with minimum agitation. So when using detergent, you should not feel any agitation, and can be washed away very easily. There is a confusion what is soap and what is detergent. There is this difference, pH value. Every student has some idea if you go by class 12 chemistry, what is pH. So pH values differs, and then this leather formation, good at removing greasy dirt, but it's not good at removing dirt. Detergent, you can imagine that. Good at suspending dirt, excellent in suspending dirt, doesn't dissolve properly in cold water. For detergent, easily dissolves in water in oil temperature. So, see, the point is, everybody has this idea, what I am uttering now. So, scum formation in hard water for soap, you will see some scums formed when you have hard water in the system. I mean, your resident or in your home, you would see that. So, detergent unaffected by hard water, doesn't matter. And not good at stain removal. So you see that if you use a soap stain on your shirt, soap won't be good, right? But detergent is very good. Yellowing at white fabrics retains whiteness of the fabrics. Now, abrasive. In our daily life, maybe we do not use it every day, but this is very important because cleaning depends on rubbing and scratching properties of materials. Now, for science students, which is the hardest material? Diamond, right? So there is a hardness scale, abrasive scale, and in a scale of 1 to 10, which shows 10 as diamond, feldspar, hardness of 6, and calcite. So fine abrasive is filtered chalk or jeweler's rouge. Medium abrasive is scouring powder, and hard abrasive is sandpaper or steel. Solvents, this is very important. These chemicals are used for removing grease, dry cleaning fabrics, stain removal. Solvents should be inflammable. They are strong chemical agents, hence used in small amounts. They are volatile. What are the examples? Carbon tetrachloride, methylated spirit, pre-chloroethylene, turpentine oil, acetone, etc. This is very known to us. pH scale. 7 is neutral. Here it goes the acidic, basic, strong here, weak here. So this is roughly the scale of acidity and alkalinity, right? Basic nature of the system. So acid cleaners, every day we use, even alkali cleaners and neutral cleaners. Acid cleaners, they include cleaning agents below 7. They are used cleaning toilets and for bathing and wash basin we use it. The varying strength, different 3 to 1. So, we do not need any presentation for that. We use it very often, these acid cleaners. Now, for greasy stains, you need alkali. So, since they are strong, rubber gloves should be worn. You will see that our cleaning Datta, they use it with gloves, these alkali things. Caustic soda based alkalis are used to clear blocked drains. Okay, so this is known to us: baking soda, washing soda, and caustic soda, liquid ammonia, and hydrogen peroxide. Neutral cleaners, washing dishes and down dusting. So, in our labs, usually we have 1 bottle of neutral cleaners for cleaning tasks. We use polish things for coatings. So polish means to provide protection to surface against dirt, stain, and finger marks. They create an attractive sheen on the surface. Before applying polish, the surface should be dried and clean removed. So these protocols are set for the last 20 years. So these are quite easy protocols for us. Buff the polish with rags and dusters, preferably on the nap surface. Furniture polish can be done paste, cream, liquid, spirit-based water. High-speed emulsion can be used as polish. There are different polishes: metal polish, furniture polish, we use it like this. Floor polishes, water-based, spirit, and high-speed emulsion polish. Even leather polish, we use it regularly. Now seals. This is very important for floors, right? Floor seals are applied to floors which form a thin layer of plastic and semi-permanent finish that acts as a protective layer. Permeable, semi-permeable, impermeable. So this is very important. I mean, there could be floors where water can go in or water can be resisted. So depending on that, you need floor seals. Function of floor seals. Floor seals increases the shelf life of floor by reducing the wear and tear due to usage. They improve on the appearance of the floor and also provide attractive gloss. Maintenance of the floor is reduced as it forms a protective coat. So coating is very interesting science where I think at least 2-3 people in IACS, they are working on it. Coating to make a surface with more longevity. So these are the different floor seals, oleo, resinous, one-pot plastic. These are all figured name. Pigmented self, water-based sealers and silicate dressings. I'm skipping this because these are all technical things which are plastic sealers and different plastic sealers, pigmented sealers, water-based sealers, and silicate dressings. So in all these slides, what I wanted to tell you that there are some applications of different detergents, soaps to clean the surface. There could be they have different features. They could be dangerous, so you need protection to use this, and they are differently classified, and different material has different properties. Now, in recent times, there are few things which has come up. I would request the administration to think about this. This is high time that we take all these recent technology to clean the system. So, improved robotics. People have started this. This is more of an international thing, improved robotics. Ultraviolet disinfection, this has been started during COVID. You may remember that UVC LEDs were introduced to clean the surface, but again, UVC LED is not good for human body. So if you have a UVC chamber, you can put your whatever mobile and other things, because during COVID we started to believe that the virus is carried by different this thing. So our whatever we touch, it contains. I mean, the initial idea was like this. So I think UVC was there, and since I was a member of this project review committee of DST, empaneled that time for those who are making these UVC systems, I reviewed many projects like this. So I understood that people are adopting this technology to make their belongings more virus-free, bacteria-free. So this is one, and then antimicrobial surface protectants. Usually they use for hospitals, and then huge amount of data creation for keeping. I mean, for everyday bookkeeping. I mean, I think a smart way of bookkeeping is keeping all these informations, whatever you are doing and whatever your reactions from the users, you need to have a database. And then, data logging. Whatever you use, there should be some data stored in the cloud. Chemical fogging disinfection and high intensity narrow spectrum light. I find this from internet. People are using this, started. This is safe for humans. Now all these, why I made this as yellow, because I mean 3-4 years back I started working on some devices which might have some implications in this IoT technology. I made a small device from little effort from my lab members. So we named that as Megnath, a multi-purpose readout device for soil health monitoring with cloud-based remote data logger. I thank my students for doing that. So it's a small box where we created a resistance meter which can measure soil resistance. If any abnormality going on in your soil, in your land, it can measure. Why it could be important for cleanliness? Because the machine doesn't know what it is measuring. It can only measure the signal. So if you can use the machine in a proper way, that can be used in different applications. So it can measure resistance, electrical resistance. Now you have to understand if your surface gets unclean or something is deposited on the surface, it might happen that the resistivity or the resistance, let's say, electrical resistance will have some change. Now, the good point about these devices, we made a IoT, Internet of Things, so we can store the data, time-dependent data in a server. So you can see this in principle in the mobile. So if you can see them in the mobile, you can track the data. So if your sensitive surface is changing with time, you can sort of track its evolution of the data. So I mean, the circuit is pretty simple, even if it looks like a very jumbled, but it's a current prototype of the system, and this works. And there is no point why it would not work, because it is standing on a very robust principle of resistance measurement. So we could, in IACS, we could see different soils, dryness, and we could turn with a color code so that even a layman can understand what it is. As you can see here, very wet to a very dry soil. So we can do that, and that's a cloud data storage. And I would say that this technology is not a very complicated one, but even with this data technology, we can store the data in your computer. So the sensor is at the playground, let's say, and we can store the data in your computer, so you can track. Okay, with this, I would like to thank the audience and for giving me this opportunity to learn about cleanliness, because this is the first time I think I read so much about cleanliness with this exercise at least. So these are some pictures I could gather from Datta. He sent some pictures, and I think more than me, that clap should go to these guys who keep our campus clean. So I think these are the guys, they are the champion people. So with this, I conclude my presentation.
I am requesting our register ma'am for the conclusion.
Thank you, Professor Datta. Thanks for your accepting our invitation and explaining the passionate science you do in a non-science language that we all could understand so easily. And it is so contextually important. All your statements we often come across at home and inside the campus. So we could get a very useful insight. Thank you all for joining here. We would expect better turn up in the subsequent programs, but even then, we all are ended. So thanks very much, Professor Datta, and also the team. Now, Obhijita is only there, but Shorini, all are working, and this will be a 2-week-long program. And we will keep on meeting and carrying out similar activities under the Swachhata. Please keep the campus clean, habit cleanliness on your individual part, follow the advices, and be with us like this. Thank you.
Hey,